put together one particular Kaggle a competitor had compiled these, but I still wanted to understand certain aspects of it better. So I put them together in this table. Can people see what I'm sharing? An Excel spreadsheet page?
Yes.
Yep.
Okay. So let me just quickly go through it. I'll post this Excel sheet on the Slack channel. Don't let it distract you too much from what you're doing right now, because as you'll see, and as I talk through this, you'll find that we're now probably going to switch and do some of these things, but some of the others give some good inputs as well. So, so this is just based off of one guy's collection of some things, but I wanted to compile it into these. What is the position of the person who made this submission, or group? Sometimes it's a multi group submission. What was their leaderboard score? Is it an ensemble or not? That's what this column is. And in a couple of cases, I think missed. So I'll go ahead and update that. Where it says Y, it definitely means it's an ensemble of networks. The other thing I would point to is, in many cases in this particular competition, I saw it was not just an ensemble that people used, but ensemble and stacking. That's something, unfortunately, I realized after I went through multiple of these. So if I have the time between now and next week, I'll try and add a line which says stacking or not as well. And just to explain what stacking, at least in this instance, seems to mean is they use a bunch of networks to feed into another net or another method, and then use the output of that to create the final output. So it's ensembling, and then in some cases it's just ensembling, which is just combining the output of multiple models. In some cases it is ensembling and stacking, which is you combine the output or you use the network to generate features which then you provide into another model, which then generates your final output. I have not, as I said, indicated which of these are stacked and which aren't. That would be something I'll go back and add, because I found out that many of these were stacked much as I had probably gone into the 6th or 7th example. So that's something else to keep in mind. Here is a list of the techniques, and I'll go through that. And then the relevant links that I used. So let's just quickly sweep through this just out of interest. Now, as I mentioned at the beginning, I think most of us, Steve, Gaut, and me, are all in in the 0.2 or 0.17. So we're all worse than this. Even the 169th score on the leaderboard the leaderboard score is about 0.14. I believe all of these are private leaderboard scores, because eventually that's what you get ranked by. I'll double check that what I say is true, but if I recall correctly, I think I used the private leaderboard score. So this is about 0.16, but what you see is how many of them are ensembles. There's very little single model that anybody used, even in any score. Any of the positions. There might be some. I didn't do an exhaustive search, but in general, most of these high scoring ones are all ensembles. The other thing, just sweeping through the techniques used, which is kind of interesting, is you can see, even the 169th score, 0.146, uses 7 LSTM models and 6 XGBoost. So it's a ensemble of 13 models, literally, I think. And then you look at the 40th. This is just an XGBoost, but I'm not 100% sure, since this left empty, whether it's just an ensemble of gradient boosting models or it's a single model. I'll double check that when I update this. I found this to be interesting, that the guy was able to score as high as being in the 40th position with just 15 one-dimensional convolutional models. Unfortunately, and I'll post the link here, he only has a description of the kernel that he used. So not all of the code that he used to get here, nor all of the features. That's the other thing I would say as I was compiling this, that I felt, and maybe I'll go ahead and add that in the future, is how much hand customization people did of the features that they fed into any of these. In some cases, as we'll see as I go down this list there, and you can see it right here, is, the 8th position used literally 1,000 features. Not obviously not all of these were hand generated, but when I say hand generated, what I mean is that it wasn't just feed the input data into the neural network or other models and out pops the result. They had to do some pre-processing to generate these number of features. This guy has scored incredibly well with just 15 one-dimensional convolutional models and an ensemble of them. So that I thought was very interesting. Second is there's a, 24th on the leaderboard, getting 0.12, and it's just based on LSTMs. Again, it's an ensemble, so I would assume this is a multitude of LSTM models, but it's at least it gives us a good pointer that using LSTMs, but I don't know with what number of features and what handcrafted features or whatever else, but at least the base model he's using is LSTM, and he's still able to get up to a 0.12988 score, which is, and if I recall correctly, this guy is a single guy entry as well. Now I'm getting, let's see. Yeah, this Airden 4 guy, I believe, if I recall correctly, was by himself, which is pretty impressive. So that's an LSTM. It is an ensemble, but it's, very significant low score in the 0.12 range. The many of the models, as you see, are all XGBoost related, and I'm not aware if anybody else can speak to it. I'll happily yield and be educated what the LBGM models are. Can anybody say something about that? I'm not familiar with that, or what that is.
I've heard of LGBM, like.
So it may be a typo that I have it as LBGM, maybe.
Yeah, probably.
But
Maybe
it's
I got it.
just a gradient boosting model again. And what does the L
Yeah,
stand for then?
I
Light.
think it's light.
It's just a Microsoft implementation of.
Oh, so it's just an LGBM.
Yeah, it's a light GBM, and it has some advantages.
Sorry, Mehul, you're very faint.
Oh, sorry. Is this better?
Slightly.
Is this better?
Yes.
Okay. I had to open my. It's an implement. Yeah, it's like you were saying, it's implementation from Microsoft, but initially we had XGBoost, and then Microsoft did Light GBM, but it has some advantages, like XGBoost has this irritating thing that you have to convert everything into integers, right? Like or some numbers. Like if you have a string like Saturday, Sunday, Monday, you have to have convert that to 0 to 7, or like 1 to 7 before you feed it to XGBoost. So Light GBM can take the string features directly, and then also it's a little better at handling missing features. And there's like almost more than 100 parameters to set for both of them. So somebody did a very nice summary of comparing the parameters for XGBoost and Light GBM. I'll just share it in the chat right now.
Yeah, that'd be great.
Yep.
So I think my apologies, I guess, as I was copying over, I might have I'll double check just to make sure I'm not missing anything. But then, in the absence of anything else, and before I post, I'll check to see. These very well could just be me flipping characters. So, but here's gradient boosting, and assuming this is LGBM, then L combination of those. Here's something which I thought was interesting. It's just ensemble, and again, impressively, he's getting down to 0.124. Combination of gradient boosting, light gradient boosting, logistic neural network. So it's an ensemble of 4 different types, or at least 2 of them of the gradient boosting type, and then a logistic, and then a neural network model. But combining those, and caveat is, I still, probably should add another column here saying features and whatever comments they made about how many features they've used. Not all of them have made comments about it, which is the reason I didn't add, but that would be more informative. Because look at the next one, which scores in this 0.12 range, is gradient boosting, light gradient boosting, random forest neural network, which you can see kind of random forest switch for logistic, but otherwise kind of similar combination of different approaches, but 1,000 features fed into them. So, what that begs you to think about is, what are these 1,000 features? And that's something else maybe I'll build below of, even if not listing of 1,000 features, at least into what broad categories they fall into. Is it distance? Is it angle? Is it, collection of what? Then you see LSTM based again. I think this guy, either I missed the link or I'll update it, but it's by LSTM and then word level and character level enhanced with the recurrent highway layers plus attention. And then character trigrams, which would be, just collection of characters, and then 1D convolution, and then all networks with and without attention. So all of these guys with attention, and then all of these guys without attention. And then he also uses contrastive loss versus the cross entropy loss. I think Yuri had pointed way back in one of our early discussions to contrastive loss. So I'll try and, can everybody speak to contrastive loss and its advantages or disadvantages with respect to cross entropy?
Yeah, I haven't. I found the paper, but I haven't fully read it. So
yeah, because that's something else I wanted to maybe spend one of our discussions, because obviously part of our goal is not just to finish the competition, but to learn as we do each of these. So I highlighted that to say it would be good to kind of figure out one of the papers. I think either Gautam posted or the Quora guys referred to or something else. I've seen the term decomposable attention. That's something else that I wanted to also dive into a little bit more and understand better, if not kind of read through the paper and discuss that in one of our upcoming things. So that's why I added these details. That decomposable attention was something worth diving into. If anybody wants to do that, please indicate to me in the Slack or send me a DM, and that'd be great if you can do that. Same thing with contrastive loss versus cross entropy loss. If you want to sign up to kind of look at that and present what it is and why and when we would use one versus the other, what are the pros and cons, that would be great as well. And then this is one you can see.
Srinivas, I have a small question.
Yes, go ahead.
So what I'm interested to know is, how do they ensemble the LSTM and the CNN models? Because the features are same anyway, right? You are just feeding in the sentences. So do they have like 15 different architectures? And even if you have handcrafted features, those would just be like appended at the end of the LSTM or at the end of your CNN, right? So do they append some features to one of the ensemble models and some features to the other models in the ensemble, or how does it work?
Yeah, I'll answer generally because I just compiled all of them, and then I was going to dive into the ones which seemed interesting to see what more data I could gather about them. So the short answer I would say is don't know, but because I have looked at some of these in more as I was compiling it, what I would tell you is in general, they don't do the last of what you said. They always, if they are doing any handcrafted features, as you were saying, they feed it into all of them. Um, but so I haven't seen anywhere only some features are fed into some networks, unless it's a part of them building. By that, what I mean is, obviously convolutional networks build this 1 gram, 2 gram, 3 gram thing, right? Because you just say con 1D or 2D or 3D or 4D, like one of the notebooks I had shared earlier, and all the way up to 6D that it used. Um, so that builds up the n-grams as it goes along. But other than that, if they are manually combining features, it's more of what you yourself said, which is, just kind of after going through the embedding, just stick the features in concatenation. At least that's what I saw in several of these, but I can't tell you that some of them didn't do something more fancy. Um, but that's why I was interested in just compiling and then beginning to dive into them depending on how much detail they provide through the links. And some of them have GitHub, um, where they have the code, but I have not gone through all of these or any of these. I've just glanced at some of them up to now. But the purpose of this was to kind of figure out even, are there any major techniques that are missing, that we are missing, or, we've been at it for a while, and to see, hey, is there anything people are doing? And as I said, some of these things like contrastive loss, the decomposable attention, those are things which we ourselves have also seen in the paper, but now or I think this recurrent highway layers is just something similar to what it maybe just be a terminology thing of, I've seen a slightly different terminology used. Maybe Mehul recalls in images. I forget what they call, not recurrent, but there is a highway network paper that recurrent highway stuff that I have seen. So I want to confirm whether it is the same thing as what he is mentioning here. So Gautam, short answer is no, I don't know the answer, and it's something I'll dive into further over the next few weeks.
Okay.
But if anybody wants to also, look at decomposable attention or, contrastive loss and share with the rest of us what they have found, and how it's used generally and how it would be used in this context, feel free to do that. I will update the relevant links and post it so that you can at least have a good starting point if you would wish to do that. And then you can see, because it's 3 years old, so many of them use gradient boosting with custom crafted features. Now, what bothers me, quite bluntly, is the fact that, without the use of custom features, or at least the modern day deep neural networks should get us to this level of scores, maybe with ensembles, or stacking, but without the use of custom generated or handcrafted features. While none of us have jumped to ensembles yet, the open question is whether ensembling and stacking BERT or some things that we already have, whether, LSTMs, for example, whether they get us to this level. And if so, how? As you can see, this one, 24th, probably this guy, although he does a little bit more magic because he has attention, contrastive loss, character level as well as word level by LSTMs. So a little more complex, but this guy is getting up to 0.129 with just LSTM ensembles. And some of the top 3 in the money guys are, again, XGB, Light GBM, and then neural network, 1300 features. And the top 2 are weighted ensemble, neural network, and then Light GBM, which seems pretty impressive given one neural network and then Light GBM, second best. And the top guy, interestingly, and Rekil had asked this question. I didn't know this when he asked it. When Dinesh was sharing his Siamese or attempted Siamese, Rekil asked the question in the chat saying, do we know whether Siamese did well in this competition? And I didn't know at that time, but apparently the winning, of course, 3 years old, but best score 0.115 was a Siamese with attention and 4 layers. As I mentioned, about the 7th or when I got here is when I started seeing this term stacking. And when I look back, it seemed to imply that they were feeding the results of, for example, a neural network into and using it as a feature generator to feed into another set of networks that then would produce the result that they were looking for. And that's what this 4-layer stacking here means as well. So again, I don't know that it would change anything that I'm playing with right now, because I still think we can get better than 0.17 by combining things. Or techniques or approaches, but that's kind of where I am at. But I just thought, I'd put this together to discuss maybe a week or 2 later when we kind of begin to run out of ideas of what to do next or how else to improve our models. But I thought that I would share that. And as I said, I'll try and make sure some of these, if this is in fact light GBM, then I'll make the typo corrections, make sure that my ensembling yes, no is correct, and potentially add a stacking column, although I don't know that every one of them mentions whether they stack or not in the discussions, and add any missing links, and then I'll post this so people are interested. But feel free to kind of use it more to see combine things, for example, or take some different approaches. The one other thing I would encourage people to do is maybe look at what are some of the cool features that people are generating as well, and how much it seems to help them. Because you can see that a lot of these guys are generating a tremendous number of features, which, if the thing that frustrates me about it is deep learning is supposed to get us away from having to do this, but we haven't yet succeeded in getting to this level of scores without using the features. So the open question to me is, in this competition, without generating these features, using the modern techniques, can we get to comparable scores? To what people have achieved 3 years back. So from that perspective, I think Gautam's choice was an interesting one of picking this because it kind of teaches us some important lessons of, hey, is deep learning solving everything? Are there still questions or problems that kind of fall in between the cracks of established, like, named entity recognition or neural language inference, so things which are largely exactly benchmarked? This one doesn't seem to fall into one of these exactly benchmarked problems that people are just constantly improving the performance of models on. Any comments, anybody? Yuri, Gautam, Steve, Arto, Mehul, anybody else? Thoughts?
About those handcrafted features, I think I saw I think that's a really good question you raised. Like, I saw I can just give you some examples from the medical domain. Like, recently, um, in the last 2 years, any medical device in the US has to be approved by the FDA.
Mm-hmm.
And the last year has been like an explosion of deep learning and AI for medical devices. They even had a full 2-day conference only talking about deep learning and AI for medical devices.
Mm-hmm.
And then one thing there was, so depending on the application. So one application, they called it computer aided triage. And so triage is like, yeah, people are coming into the emergency room, right? So
Right. Yeah.
like,
They prioritize the handling of them, right?
right. And so nowadays, especially with COVID, sometimes we are hearing people are waiting for 7 or 8 hours. So these the company that released the algorithm and it got approved is for computer aided triage. And I think there they didn't have handcrafted features, but there's another application where there's a lot of work in oncology. So like, okay, so you say let's say, Srinivas, you say you have a new drug to cure cancer, right?
Mm-hmm.
So people are trying to see from the images, can I predict uh, how this person will respond to the treatment? And for lot of this type of analysis, I see a lot of handcrafted features. I think there is a lab in so Cleveland Clinic is one of the top
Right.
medical, yeah, and they are doing a lot of handcrafted features. Even now, even in 2020, they are like, um, and I think they are making an effort to stay away from only deep learning and still doing get the domain. But just I think like the triage was like, yeah, total deep learning, but in some other application they're still doing like handcrafted
Handcrafted.
features.
Yeah. So that's the thing which interests me about this one is, is it the nature of this problem that without handcrafting, you wouldn't get to the best levels that people have gotten to even 3 years past, or because it falls kind of in between, solved, quote unquote, solved or optimized problems? Or is it just that we haven't pushed modern techniques and done the ensembling and all this kind of stuff to where if we did that without these features, we can get there? I mean, that's a question that definitely is in my head as I see these results and what we have seen so far. I don't know, Steve, Gautam, you have thoughts?
I was just wondering, like this problem is used as a sort of benchmark for BERT and stuff coming out. It is one of their test problems. And yeah, like if you look at sort of the best performance on the Quora question pairs problem, yeah, like BERT was up there. And yeah, like now there's one Excelnet, which is a new sort of advanced version of BERT. I was wondering, when they're doing their benchmarking on this problem, are they also doing all this handcrafting? Are they sort of playing about with the features and stuff? And like, is the benchmark problem that they use to assess how good like a BERT model is it directly comparable to this Kaggle competition, or is the Kaggle competition, are people getting just good scores because of the fact that they're just using a sort of cut down version of the problem?
Yeah, that's a good question. Don't know.
Because if you go, yeah, like if you just like sort of like Google for sort of the best results on Quora question pairs, it comes up with like with BERT and stuff. But obviously, like when I tried to run BERT on it, the results I got were half as good as the results here in this list.
Yeah.
So it would make it look as if sort of the new techniques are better, but I don't know why I haven't been able to recreate that yet.
Yeah, that's my. And is it just the fact that these guys are ensembling 15 models and
yeah, it could be that. Yeah.
yeah. Right. But at the same time, I'm also kind of intrigued by like results like these two, right? Where, yeah, it is ensembling 15 models, but it's just 15 convolutional models ensemble. Now, what I don't know, and that's an open question, unfortunately, we may not be able to decipher that because the kernel only says this guy just discussed whatever, hey, here are a few things I did. And if he doesn't have a GitHub code things and stuff, then it's very hard to figure out what features and what did he actually do, he or she or the team, if you will. But on the other hand, this LSTM model, the guy has a GitHub posting. So from that standpoint, anything that has GitHub postings are good because then at least the code is there, so you can go pour through that to see what they did or didn't do. Gautam, any thoughts?
No, not really. I mean, the question that you asked is good, but yeah, I think that to the question that Steve asked, I think the benchmarks that you see on like sites like Papers with Code, I think they are without handcrafted features. They are probably the base model. I mean, they would have done some modifications, but I doubt that they would have added any handcrafted features. That's what I feel.
Yeah, no, I would tend to agree with what you're saying because that wouldn't lead for a public comparison if they handcrafted things, right? Because they would have to include that in their results.
Yeah.
I would
And
also
BERT,
think they are not ensembles, right? Because if they ensemble, that is something else they would have to mention too. Like, this result was obtained by ensembling like, 3 models or blah, blah, blah.
and the normal vanilla BERT, I mean, its performance is not that good, I think. Looking at the benchmark, it's at 17th rank, which is 72.1, and the next best one is 83. So
Oh
there's like
yeah, yeah. Like I realized, sort of like BERT is a bit sort of old school these days or whatever. And as I say, like when I looked at the list, it was like Excelnet or whatever was getting the top score or it's top of the charts in the benchmark test. But yeah, like it's just some advancement in BERT, isn't it? So
Where do you see this benchmark?
I think I just Googled for a Quora question pairs benchmark leaders or something like that, and yeah,
I've
so
pasted it in the chat.
Ah, cool. Yeah. So, but, just several things to pursue a bit more until we understand few of these things. And I'll also dig up by
Okay,
next week.
that's
Go ahead.
I think I made the same mistake as last time. This is question answering on Quora question pairs. Steve, did you see the same thing as I pasted? So this one's question answering on Quora question pairs, not question pair similarity. I think so. This one has Excelnet at the top.
Oh, perhaps I was looking at the wrong thing then. Yeah, maybe. Yeah, I think this is what I was looking at.
Maybe I'll stop sharing and you guys can show what you were. If you can show what you're looking at.
No, actually, yeah. So what I was, so the link that I shared was this one, which is question answering on Quora question paste. So
Okay.
probably this is what Steve looked at as well.
Yeah, that's what I looked at. That's where I saw Excelnet. I didn't realize it was a different competition.
Yeah, see, because at least when I looked at, and that was where what I was going to do next, the Ottoman, Steve, typically, much like this semantic segmentation, the thing I've been rambling on about is unfortunately or fortunately, depending on your perspective, this Quora question, similarity doesn't exactly map to a single task that most NLP guys or algorithm focus on and optimize. So it seems to fall. I'm talking from memory, so I'm probably going to screw this up, but it seems to fall between two tasks. One of which is semantic understanding, or there's a better word. The second word is not semantic understanding; it's semantic something. And then a different task and that I forgot the name of. I have bookmarked both those, and I'll post that in Slack going forward. But it brings together those two tasks, so it kind of falls into a combination of the two tasks rather than a single task, like this. And one of them, by the way, could be paraphrase identification, and the other one is semantic identity or semantic something.
Text similarity.
Sorry, Yuri?
A semantic text similarity.
Semantic text
STS.
similarity. Yes, that's probably it. So it's, between paraphrase identification and semantic textual similarity. So it's those two, but it doesn't exactly map to either one of them. It's a combination of those two.
So this might be the right one, right? For the Quora question paste, which Mehul just shared.
Yeah, paraphrase identification, right? But even this isn't exact map, because what this does is it says, is this question a paraphrase, or actually no, if I recall correctly, and Mehul, if you know more, correct me, but I thought this is is a paraphrasing of one the same as the other, not are the two questions the same, and there is a difference between the two, I think.
Can you explain that again?
Sure. So see, in our case, we are just saying, is this question the same as the other question, right? My recollection, and I could be wrong, and I'll spend time, as I said, it's been a while since I bookmarked those two things. But I believe this says paraphrase identification says, if I paraphrase something, is that the same as a different entity? Meaning, I'm generating a paraphrase, and then is that the same as the other? Not is the question the same as the other? Is the paraphrase I'm generating from two questions the same? I think that's my recollection, but I could be wrong. So, sorry, was Mehul sharing that, or who was sharing the paraphrase identification? Because we can just look at what that task is, at least. What's the definition of that task?
Okay. Do you want me to share it again?
Yeah, if you could please. Yeah, what does they define as that task, Oh, there, yeah.
Yeah, it's the same thing, I think. I determine whether a pair of sentences have the same meaning. This is what the task is, right? In our Kaggle competition.
It should be this. Yeah. And what did they say is the best thingy? Best method is mtdnl. Okay. And it's about not at about 90% and span bird.
So, sorry, how did you get to the task description? I missed that part. And
I clicked on this.
One, yeah.
Okay, one level up. Thanks.
Yeah. Yeah, that's interesting.
Okay.
Yeah, that'd be interesting to see. So it seems like Spanbert or something else seems to be what is generating. Yeah, I'll look at that because anyway, I'll wait to identify and talk about that as to, because that would be also something to look at is what paper or method they talk about, and is it possible to apply that method to the Quora. Obviously, that paper, I assume, has applied it to the Quora question data set from what you shared, Gautam, right? Because the data set was Quora question pairs, right? For that
Yeah,
data.
but yeah, I don't think they would have the actual code which runs on the Quora question base. I doubt they have that.
What do you mean?
You no, I were you asking if the code for the implementation is available?
No, what I was saying was the data set that they are using is the Quora question pairs data set, correct?
Yeah. Yes.
Yeah.
Yes.
Okay. Okay. Yeah.
Also, the paper that I shared a couple of weeks ago,
Mm-hmm.
like even that one would be in the top 4
On
actually.
that list, the paraphrase
Yeah.
identification.
And it was not that complicated a model as well. It's just LSTM with, I mean, it is complicated, but
Yeah, but it's
just some
foundationally
additions with
built
LS.
off of LSTM, right?
Yeah, with
By the
attention
way,
as well.
can you go back to that link? Is that paper there in the top list there?
It's not the model that I shared was ESIM.
Hmm.
It's a specific model made for like comparing two sentences.
Okay.
But for some
So
reason, it's not there in this list.
So comparing two sentences is, do they talk about what's the terminology for that task?
I think the original paper was made for some other task, and this guy just modified it for the Quora question pair similarity task. Let me see if I can find the paper.
Yeah, that's something I haven't gone through. I'd like to go through that too. The paper you had posted.
The original paper was for natural language inference. The paper is called
NLI.
Enhanced LSTM for NLI. So the entailment, contradiction stuff. They just modified this architecture for this task.
Sentence comparison task.
Yep.
Okay, that's fascinating.
Oh yeah, I saw it just because I was looking at the number one Kaggle description from your list, and that was one of the networks that he used. He used the decomposable attention and ESIM.
Yeah, I'd also like to precisely understand what this decomposable attention does or is, because I've seen the term used, but I can't claim that I know what it exactly means. Does anybody, do you know, Gautam, off the top of your head?
Nope.
Okay. Because that's something else I'd like to grasp what it means. So it'd be worthwhile diving into that to see what is decomposable attention and how that helps compared to, traditional attention.
So,
Cool.
so I have this question. So I looked at as I said, I looked at like the best score, the best score, and he describes the stacking, and he looks.
Yeah, that's why I said he said stacking of 300, 150, something,
Yep.
something. Yeah.
That's so it's 300 in the first level, and then 150 models on top of that. That seemed. I understand he wants to win, but he wanted to win, but that seems excessive.
Yeah. Sometimes Kaggle, I mean, even the whatever the 160th was like, I was, wow, 8 LSTM models and 7 gradient boosting or something like that. And, he's at 169th on the competition. So, yeah, people
I think
do.
maybe we should compare with the best single models.
Yeah,
With
that's
that,
something I was thinking of, but then digging through it to figure that out is going to take a little bit more effort.
oh yeah.
But by the way, that LSTM thing, it said ensemble, but I'll double check whether it is or it isn't. Because, you'd have to scan. I mean, this one was something that I found the reference to all these compiled already. So I thought, okay, let me, even there, right? He just says, here are the links. But I mean, from that, you can't gain anything unless you put together something which is, okay, what is the methodology, what is the technique they've used, or what features they've used. Otherwise, it's just like, okay, I got this score and here is the link. I mean, that doesn't tell us much. But yeah, your point is good one. I think if we can see, and in some of the other Kaggle competition, I've seen people compiling exactly what you said, saying the best single model, or even people report what they got with the best single model, which will help us compare apples to apples. So I'll poke around to see, but it's going to be much more effort to dig that up. But you're right. It would be interesting to see what's the best. That's where I was wondering, are we, in fact, one of the reasons I was doing this was also, are we close to what you could get best with single models by the time you get to 0.1 something? I don't know that's the case, but it's a good question. And I would invite people to kind of dig through stuff or think about it or try things and then report back. Because I think Steve is at very close to 0.1, 0.2 something, very low. And I'm at 0.18 or 0.17. But is that the best or can we do better? So those are all interesting questions.
Also, the metrics these guys have reported in the benchmark is accuracy. So I don't know how they got it. Did Quora give them like special metrics? I don't know. Because we don't have access to accuracy, right? We get log loss.
Yeah. You're saying that when the bird guys and stuff report, it's often accuracy, right? Or
Yeah.
F1.
Yeah. I mean, how did like the on the Kaggle we don't get the accuracy, right? We get the log loss.
Yeah. Yeah. Yes.
They must have sent it directly to Quora. I don't know.
Yeah, that's interesting. Cool. Any other comments or inputs? Dinesh, I see you've joined. Any update on any luck with your Siamese?
No update. Sorry, Srinivas. I have not been able to get back to
Doing that, yeah, and all busy catching up with a bunch of stuff. So no, don't need to apologize. We do this more, keep ourselves learning, and so I
Yeah,
was
I
just
need.
curious whether you saw some results. So
Yeah, I have. probably this week I'll try to get back to it.
Yeah. Cool. Okay. Thanks everybody for joining. I'll post the Slack, and there's some interesting questions to pursue, discussions from this week that I'd encourage people to look at. So we can, and I'll also poke around in the forums and see. I think I agree with Gautam, like, for an apples to apples, let's see whether we can get what's the best, if I can find enough people pointing to, and I'll post an updated version of the table once I've double checked some things and corrected my typos and things like that. Okay. Cool. Thanks everybody for joining, and we'll meet next week, same time.
Thank you.
Cheers. Thanks.
Thank you.
See you next week. Bye.
Bye.